I'm Dr. Kenneth David Strang. My colleagues call me Ken. I'm based in the Caribbean area of USA. I'm presenting this study called The Impact of Vocational Motivation for Teaching ICT Online during the COVID-19 coronavirus pandemic in Sub-Saharan Africa. Presenting this on behalf of my colleague and co-author, Dr. Narasimha Vajjhala. Rau is based in the New York University at Tirana, Albania. And at the time of our research study, he was based in American University of Nigeria, which is where we collected the data for this project. Okay, now let's look at our motivation and the problem. Rau and I are multidisciplinary researchers and professors across topics such as computer science, management information systems, business, and others. We're delighted to contribute to the IEEE IST-Africa conference. IEEE is a well-known, reputable association of global technical professionals. They have, roughly 500,000 members, and quite frankly, many more contributors. We're also members of the Project Management Institute. They have 600,000 members, as well as the Association of Computing Machinery with 100,000 plus members. And again, these associations have many more contributors. The rationale for this study was to examine the effectiveness of a transnational education strategy in Africa. This refers to a developing nation, in this case a Nigerian university, adopting the curriculum from a Western country, USA, for the goal to expand the market and make more money. Note this is different than internationalizing the curriculum, which refers to adding interdisciplinary and cross-cultural content. In 2020, everyone around the world was impacted by the COVID-19 coronavirus pandemic. We had to move ICT courses online, which refers to difficult to teach lab type content such as application programming, software design, infrastructure planning. We were also faced with sociocultural differences between foreign professors, ourselves, teaching topics from a Western USA-based curriculum to local Sub-Saharan African students. As you'll note from the details in our scholarly-based paper accompanying this presentation, at the time we initiated this project, there was no comparable study. Our research question was, is student learning effective when the Sub-Saharan University adopted the American-style curriculum, when we were moving our ICT courses online, and teaching to a domestic student population who had a social culture and learning styles different compared to ourselves. The unit of analysis was a causal factor relationship of the demographic and pedagogy factors regressed on student learning. The demographic factors included age, gender, and socioeconomic status, as well as culture. Pedagogy factors, there were 3 of them of primary interest. The design and content was the first one, which included the topics, cases, lectures, examples. The second was the active learning engagement, which was how we taught using hands-on lab work, project teams online. The third one was vocational motivation, which represented the link to careers or employment, which also covered things such as guest speakers. And finally, the dependent variable was learning effectiveness, so in this case, a proxy for grade. Okay, let's look at our research design. Our ideology was post-positivist, which means that we were fact-driven. We collected primarily quantitative data types. We had ethical approval from the university. Our population was African-based higher education institutions who had recently adopted the transnational educational strategy from USA. And the content of a degree program was related to ICT. The sample was a non-random convenience. It was undergraduate students taking the same 3 ICT courses across 2 semesters in 2020. Final sample size was 84 cases. We collected data using a previously validated instrument, course opinion survey, which used a 5-item, 5-scale Likert type, where 1 was strongly disagree, 3 was neutral, 5 is strongly agree with whatever the question was. And of course, we collected the data on a self-report basis from the students. I used parametric statistical techniques such as factor reliabilities, correlation, t-tests, multiple regression with partial and semi-correlation, and I did that in SPSS. Okay, in terms of outcomes, for preliminary results, the descriptive statistics were that most of the students were domestic, less than 5% recorded being based out of Nigeria or international. 62% were male, and this is comparable to the industry benchmarks that we were reading and using from the home-based institution. The age group was 18 to 20 years. There might have been a couple of students there that were 21 when they finished. So the mean age was 19. Standard deviation was a little higher than 1. The survey instrument, of course, opinion survey reliability was validated for all the on all the cognitive type data items. In other words, when you're asking your perception, the student's perception on a factor, you want to make sure these items, align or load on or relate to a specific factor, but not to other ones. So for the design content, Cronbach alpha was 0.75. That was great. There were 5 items. I also produced Hotelling's trace squared. Is another benchmark, another estimate just to show that the reliabilities were valid. The second factor, active engagement, again, very high, even higher at 0.92. So the Cronbach alpha, I also listed the average interclass correlation, which is pretty much the same calculation as Cronbach alphas. There were only 3 items in that case because I dropped 2 due to they weren't loading on the correct factor. Some of the questions, maybe had some problem with the wording. The third factor was vocational motivation. This one had a few problems. The Cronbach alpha was 66. Although the means of all of these were very high, design content was 4.7 rounded. Active engagement was 4.5 out of 5. And vocational motivation was 4.7. The problem with vocational motivation was that there were some items that did not necessarily load on the factor for all students. So I accepted that factor as being reliable, although it was kind of on the borderline. I would have preferred to see a 0.7 there. And that came back to haunt me later on in the statistical analysis, as I'll discuss later. Okay, now I want to focus on the hypothesis test results. I should point out that there are a lot of details that I omitted from my presentation. We have a large literature review in the paper where we developed hypotheses. So I'm really going to cover the results of those here. I partitioned the study into 2 types of hypotheses. The first was what I would call control variables, and these were population comparison tests with the goal to illustrate that the transnational education strategy that from where it was being adopted from had a comparable population in terms of students to where it was being implemented in Sub-Saharan Africa. So I wanted to be able to show that there weren't, some really major differences in these two populations. And three variables were used really to illustrate that here. Mainly that the dependent variable, student learning, was no different than the benchmark. A two-sided, not greater, not less than, using a one-sample t-test, produced value of a 0.9, and of course the p-value was bigger than 0.5. The means were very close, 4.6 versus 4.5 for the latter for the Nigerian university. That was the parametric test, by the way. We didn't need to use the Wilcoxon or another alternative distribution-free method because we had continuous data types there. Student age, also continuous data type, had a similar t-test, not significantly different than the cohort. From the benchmark site, the gender was also similar between the two populations based on a proportion test. So the second category, so basically those control variables I accepted as being as hypothesized. The second category were the test variables, where we wanted to determine if the three factors related to pedagogy could predict student learning. More effort put into these factors should equal a result in higher student learning. The first one, hypothesis H3, design content could predict student learning, was accepted. So I used different types of regression methods, stepwise regression, several models. Bottom line is that with just that one factor in the model, the effect size was about 73%. An adjusted or coefficient of determination, or R squared, was 0.72. Very low standard error, which was what the SE in my models. The F test, had a fairly high result of 211. But one of the interesting red flags that appeared at this point was that there was a negative beta coefficient that appeared. And I'm going to discuss that on the next slide. The second model that it produced, which also had this factor in it, continued with this projection in a linear regression model, having a negative beta coefficient of minus 0.662. T-test estimate was a minus 14.6, and that was significant. So HC was accepted, but requires some discussion to explain that. The H4 active engagement factor was clearly very influential. Flag factor is accepted. The model, in this case model 2, beta coefficient was 0.498. Standardized beta was a 0.41. The t-test result was a 9.3. That was significant, so that was accepted. Fortunately, the fifth hypothesis, that vocational motivation would predict student learning, was not supported. The beta coefficient was weak at 0.282 with a standardized of 0.112. The t-test estimate was less than my benchmark that I would accept, which would be a 2. In this case, it was a 1.286, and of course the p-value was a 0.2. So, I would be looking for a 0.05 here, because my confidence level here was basically a 95%. So I'm going to discuss these a little bit more in my next slide. I could lecture for the entire presentation on this one slide, but instead I've highlighted some areas on the slide in red and green. Hopefully you're able to see the different colors to focus on particular aspects. essentially what I have here are two different models. The first model has 3 factors in it. Second model has 2 factors, which was the final model, or a better model, refined model. The first model, and you'll notice that both models are very similar in that the coefficient of determination, or the R squared, or the effect size, are both about 87%, which, by the way, is a very large effect size. The difference is primarily the F-test result, where the first model had a 178, whereas the second model had a 264. And what that tells us, with similar, standard errors, was that the degrees of freedom, which are in the parentheses after the F, as in 3,80 and 2,81, those, and the fact that we were creating a more precipitous model in Model 2 with fewer factors, was really showing that we could produce a much better model in the second round. Okay, so what happened was that the design content had a negative beta, and one of the things I looked at first, and by the way, the column headings here, the standard is a standardized beta column. So you've got beta, standard error, standardized beta, the t-test score, the p-value, zero correlation. And that column is the bivariate correlation, the zero order correlation column, and I've highlighted the negative 0.852. And that tells me that this factor, design content, is related to learning effectiveness, grade, but in reverse fashion, but very strongly. I mean, it's one of the highest correlation, bivariate correlation in the model. So these are all the zero order correlations, or specific bivariate correlations. The other thing, obviously, is that I want to highlight was that vocational motivation had the p-value that was too high, so it was immediately rejected. There's a little bit of explanation that can be interpreted behind the scenes if you look at the partial correlations and the semi-partial correlations, which I've highlighted, along with the tolerance and the variable interference factor, variable inflation factor scores, the VIFs in the last column. The tolerance and the VIF, they're related, they're reciprocal to one another, so I didn't highlight the tolerance. So if you take 5.881 and divide that into 1, you'll get 0.17. So the partial correlation basically tells us the proportion of the variance in the dependent variable learning effectiveness that was explained by the factor, let's say, for example, design content or active engagement or vocational motivation, but not explained by all the other independent factors. So basically the shared effects are removed, so you're controlling for the other factors. So that's always going to be less than a bivariate correlation, because you do have the other factors in the model, and this is a one-factor model, of course. But it gives you a better reading of what that factor, how that factor impacts the change in the dependent variable in a linear regression model. In conclusion, student demographics of age and gender did not impact learning. Our models had an 87% effect size to predict student learning. Design content had a negative beta because we think there were differences in student learning styles. Reading and listening to lectures online through the smartphone was a lot different than going through the graded exercises using a laptop. The active engagement factor was as we expected and the most influential one in the model. Students benefited from the labs, the online labs, and the team projects. We think that vocational motivation did not impact learning due to a lack of student workplace experience, their immaturity, and perhaps also the social cultural differences. Should note that the limitations of this study is that it was a non-random convenience sample in Nigeria with 84 cases, and it was 3 courses over 2 semesters. And there were very skilled professors involved with published research methods and teaching online, which might be hard to replicate in other studies. The implications of interest to stakeholders is that student learning was very effective and on par with the benchmark. We found Nigeria was a very interesting case study. It's the most populous country in Africa with 200 million people. It's actually the 6th most populous country in the world. It's highly industrialized with a good communication infrastructure. We assert that the results were generalized to other African universities. And the bottom line is that we assert that the transnational education strategy helps students learn effectively and allows the university to get a quick market advantage.